Dear learners, my name is Dr. Subhasis Das. I am working as Associate Professor in the Department of Electronics and Communication Engineering, SR University, Warangal, India. Today, we will discuss about some numerical problems on the topic of operational amplifier. Okay, so before going to describe the actual problem, we will try to learn about what is open or how they can function. Okay, so this is my channel. Please do like, share and subscribe, and also visit my channel regularly for updated videos. Okay, so operational amplifier is based on the principle that it will perform some mathematical operation. Okay, so here as we can see that it can do multiple mathematical functions. The first problem we will see here that it is saying that the hospital is designing an ECG monitoring system. The engineer wants only frequencies below 150 Hz to pass through while rejecting higher frequency noise. If a capacitor of 0.1 microfarad is used, we have to determine the resistor value which will be required for the purpose. Okay, so as you know, before going to jump into solving that problem, first we need to look into the problem very carefully and try to see what are the conditions and what are the given parameters we have, right? So that we can see that here it is mentioned, you can notice here that okay, so here you can see that it is showing that 150 hertz and below. Okay, so that means this is an high pass filter, right? So what we can see here, sorry, it's my mistake. So it will be a low pass filter because it is asking to pass only the frequencies up to 150 Hz and reject all the other frequencies higher than that. That means we can see that this is a high pass filter, right? This will be a high pass filter. Okay, high pass filter, right? And to design this, we need capacitor and resistor along with the op amp. So here the value is also mentioned, or the capacitor value is mentioned as 0.1 microfarad, right? Okay, so now we'll try to see how we can solve this problem. Okay, to find the value of the resistor. Now here, as you can see, as we know, the formula for this is R is equal to 1 upon twice by Fc Fc multiplied by C. Okay, right. So where Fc is equal to the cutoff frequency. Okay, cutoff frequency, right? So that means here the values are given. The cutoff frequency is 150 Hz and the values are given like this. Okay, so here what is mentioned that Fc is equal to 150 Hz, right? And the value of C also given. So C is equal to 0.01 microfarad. That means 0.01 into 10 to the power minus 6 farad, right? So we'll put all these things here to find the value of r. So the final equation will become 1 over twice pi, that means 2 into, sorry, so 2 multiplied by 3.14 multiplied by 150 multiplied by 10 to the power minus 8. Right, understood? So why 10 to the power minus 8? Because the capacitance value is 0.01 into 10 to the power minus 6. So that means it is 10 to the power minus 8. So now we can solve this problem, and finally we get the value as 10 to the power, sorry, 10.61 kilo ohm. So the value of the resistor is 10 to the power, sorry, 10.61 kilo ohm. Okay, so that means in real world sometimes it may be possible that exact 10.61 may not be available, so we'll use 10 kilo ohm. Okay, and in that case little bit it will not match the value, but in reality we mostly use 10 kilo ohm resistor. Okay, so this is how we can find the value of the resistor for this kind of low pass filter. Now we will see the circuit diagram for this. Okay, let's see how the circuit, and we will draw the circuit now. So here what we can see, that we'll draw the filter, right? So this is our op amp. Okay, and as you know, for the low pass filter the capacitor will be connected here. Okay, so it will be connected here, capacitor will be connected here. Okay, and then it will be grounded again, and a resistor will also be connected here along with the input voltage Vi. Okay, and here, as you know, here it will be connected like this way, and this will be grounded as well, right? And this resistor we are calling this Ri, this is called the Ra. So these two resistors are for the gain. Okay, so for the applicable current gain, the voltage gain. Okay, so this is how we can find the circuit diagram for the low pass filter, right? So this will be the circuit diagram, this will be the T output. Okay, here what we find, the C value is 0.01 microfarad, and this R value we got from our equation. This R is equal to 10.61 kilo ohm. So this is how we get this value, we are calling R, and we have found this thing, right? So now we understood about the uh, problem of low pass filter by using op amp, and how we can find the value of R, or in the case R is given, we can find the value of C, while the cutoff frequency is also given to us, right? So in that case we understood that, okay, so there are three parameters we require. One is cutoff frequency, one is resistance R, another is capacitance C. So if any two is given, we can easily find the third one. Okay, so from the scenario we have to first understand whether it is low pass or high pass, then we will go for the solution by understanding what are the given values to us. Okay, okay, then let's go for another problem, right? Okay, so problem 2, the problem statement is like this. In a music system, the designer wants to block unwanted humming noise below 50 Hz before the signal reaches the amplifier. Okay, so here if the resistor used is 68 kilo ohm, then we need to calculate the capacitor value required. Like the opposite thing. Just now I explained that if the resistor value is given, we can find the capacitor value. If the capacitor value is given, we can find the resistor value provided that we know about the cutoff frequency. Okay. Anyway, for this problem, let's understand the scenario first. Okay. So here, what we see that the designer wants to block the unwanted humming noise below 50 Hz. Okay, what is humming noise? We will not spend time on that thing, but that noise which is below 50 Hz. So this is the important thing. We need to understand that 50 Hz is the cutoff frequency for this, and we want to block the frequencies below this point. That means this will be a high pass filter. Okay, this will be a high pass filter. Okay, by the way, let me check the before the previous one. Sorry for the inconvenience. I cannot check the previous one. So here, what is happening? We will see now. So what we understood that this will be a high pass filter, right? Now we will see what are the values given to us and what we need to find, right? So what are the values given to us is, so what we understood first is that this is high pass filter, right? And here, as we know, the formula of C is equal to 1 over twice pi F multiplied by R, right? So this is the formula. And what are the given things? FC is given, which is the cutoff frequency by the way, and it is given here as the 50 Hz, right? So 50 Hz is the cutoff frequency, which is the value of FC, and R value is 68 kilo ohm. That means 68 into 10 to the power 3 ohm, right? So we will put all these values here, and this will become 1 divided by 2 multiplied by 3.14 multiplied by 50 multiplied by 68 into 10 to the power 3, right? And this will give us the value. If we calculate, the value will become 0.0468 microfarad. Okay, because it is coming in the 10 to the power minus 6 range, right? So now we find the capacitance value is 0.0468 microfarad, or in other words you can write also 0 point, anyway, leave it. You don't need to convert it to the nanofarad. Microfarad is the standard uh, convenience for the people, so we will not go for the nanofarad conversion. Okay, so now what we will do, that we will design the filter, right? So we will use the same kind of circuitry, but here one difference will be there. We'll see that this is the open, okay, right? So similarly we'll get the output from here, and we'll have these circuits Ri along with the feedback register for the gain setting. So this Ri and Rf will set the gain of the amplifier, but the filtering circuit will be attached to the non-inverting terminal. As we noticed, for the low pass, the capacitor comes down in the shunt condition towards the ground, while for this one, like this one is high pass, so we will use C here and R here. Okay, this will be grounded, and here we will connect our DI. Okay, so here R was already given, so R was 68 kilo ohm, right? And your C value we found here, the C value we found is equal to 0.0468 microfarad. Anyway, so this will be the design of that your high pass filter required for that rejection of humming noise by using operational amplifier. Okay, fine. So now you understood how to design the high pass filter and the low pass filter if any value of resistor or capacitor given along with the cutoff frequency is given. Okay, so it will be now easily handled. So two things to remember, that for the low pass filter, the capacitor is connected to the non-inverting terminal and shunted to the ground, and the resistor is connected in series with the power supply, and this is also connected to the non-inverting terminal. Another point you need to remember for the high pass filter is that this capacitor and resistor condition, that position will be interchanged. That means this time the resistor will be connected from the non-inverting terminal and shunted to the ground, and the capacitor will be connected in series with the power supply towards the non-inverting terminal. So these are the basic difference while remembering to design the high pass and the low pass filters, right? Okay, so we will see another problem now, right? Okay, this seems little bigger, but maybe the scenario is bigger, actual problem may be little smaller. Okay, we'll see now. Sometimes these scenarios are given such a way to confuse the people, but we will take the gist from this scenario. Okay, let's see the problem statement. Okay, so a seismic monitoring instrument installed near a dam records both actual ground vibration and high frequency electrical interference from nearby machinery, right? The engineer wants the circuit to preserve only signals below 25 Hz while attenuating the higher frequency ones. If the capacitor selected is 0.22 microfarad, determine the resistor value required. Okay, so this is basically is asking you to design a filter which is like frequency filter, of course. Now we have to decide which type of filter, whether it is high pass, low pass, or some other kind of frequency filter. So as you can understand that the engineer wants the circuit to preserve only signals below 25 Hz. Okay, that means 25 Hz is the cutoff frequency while attenuating the higher frequency. So attenuating the higher frequency means below this frequency we are allowing, and above this frequency any signal we are trying to attenuate them. That means this is a clear case of low pass filter, right? this is a clear case of low pass filter. Okay, we will see this. We already noticed in our previous problem how to find the values of low pass filter, right? So that means we can see this thing. Okay, let's find the values. Okay, here as we know, the value of R is denoted by 1 over twice by Fc multiplied C. Okay, and here Fc, which is the cutoff frequency, is equal to 25 Hz, right? And 25 Hz, and the C value is given 0.22 microfarad. If we convert, it will become 0.22 into 10 to the power minus 6 farad. Sorry, yes, 10 to the power minus 6 farad. Okay, now we will put this all these values 1 over 2 into 3.14 into Fc. Cutoff frequency is our 25 Hz multiplied by 0.22 into 10 to the power minus 6. And if we calculate this equation, we will find that the final value becomes 28.9 kilo ohm. Okay, so this is the value of R required for our purpose of designing this low pass filter, which will help the engineer to uh, attenuate the gain after this frequency. Okay, now we will see how we can design the filter. Okay, as we have already noticed, we will see the similar kind of circuit. I will just try to quickly draw this. This is the op amp, this is the output we will get, and from here we will do the similar thing. We will connect the input register and we will connect the RF. So this is your input register, this is your RF, this is your ground, and we will connect the register here along with the input Vi, and we will connect the capacitor here because this is low pass, so we will connect the capacitor in some condition from the non-inverting input, and it will be grounded. Okay, so the C value is already given, which is 0.22 microfarad, and the R value we just found. The R value is equal to 28.9 kilo ohm, right? So this will be the design of the filter. Okay, so this is the answer of the question, that the value of R is 28.9 kilo ohm, and the design of the filter will be like this. Okay, understood everyone? Now we will see some other problem. Okay, okay, so in this problem, the problem statement is saying that a smart grid monitoring system receives sensor data mixed with switching spikes from power converters above 2 kHz. Okay. To reduce these unwanted components, the engineer uses R is equal to 4.7 kilo ohm and C is equal to 0.1015 microfarad. Determine the cutoff frequency. Okay. Okay, so we'll try to see which kind of filter it is asking, and then we will see. So this is the sensor data mixed with switching spikes from power converters above 2 kilohertz. So that means this will be a low pass filter, right? But here the cutoff frequency is not given. It is we have to find. Okay. So we understood that this will be a low pass filter, right? Now we will see how to find the cutoff frequency. Okay, so as you know, the frequency for cutoff frequency formula is 1 over twice by RC. And here the value of R is given as 4.7 into 10 to the power 3 ohm, right? Because it is given 4.7 kilo ohm, so we will convert this and we will find that it is 4.7 into 10 to the 3 ohm, and the C value is given 0.015 microfarad, right? So that will become 0.015 into 10 to the power minus 6 farad, right? So we'll put this value here and we'll see that it becomes 2 multiplied by 3.14 multiplied by the value of R, which is 4.7 into 10 to the power 3, and this is also multiplied by C, 0.015 into 10 to the power minus 6, right? Okay, if we solve all these things, what we'll see is that the value will become 2257 hours, and if you want to convert it, it will become 2.257 kilohertz. Okay, so this will be our cutoff frequency of our design, right? Now we'll try to see the design of the filter. As we have already understood that this will be a low pass filter, so we can design this kind of filter very easily by the help of our previous knowledge of circuit designing. So here also we will take the similar thing. Operation amplifier, this is the inverting end, this is the non-inverting end. We will get the output from here, and because this will be connected to the inverting part, this is our input, and this end will be grounded, and we will connect the feedback resistor RA, which will decide the gain of the amplifier. So this, because this is inverting amplifier, the gain will be set differently. Okay, but here we will see another thing, that we will connect resistor and capacitor. Sorry, that this will be okay. Here we will connect the capacitor. Okay, here we will connect the capacitor, and here we will connect the P input. Okay, and as we know, the R value is given, R value is 4.7 kilo ohm, right? And the C value is also given 0.015 microfarad, right? So this is the design of our filter. Okay, and what we understood from this, all these problems solving, that first, from the scenario we have to understand that which kind of filter it is asking for from the conditions given in the problem, right? And once we determine whether it is low pass, it is high pass, it is band pass, it is band reject, like that, so we will design our circuit by these things. Okay, and these are simple problems we discussed based on the first order high pass and low pass filters. Maybe later we can discuss some other type of problems which may involve some little difficulty to understand the scenario. We will see those things in our later videos which will be coming up next, and there we can clear our understanding in a better way, that how we can design the low pass and high pass filters by using a selective resistor and capacitor network. Okay, so These are the some problems we will discuss in our next video, and thank you for watching the video. See you in next video. Okay, thank you for watching, and in the upcoming video we will discuss some of the problems related to the numerical problems which is related to the op-amps also, and as well as it will cover the operational amplifier based low pass high pass filters related problem, as well as the other things. Okay, so see you in next video. Bye.